So this is now 1 billion to a billion years. And I call it the age of the dark matter. And basically what's happening now is that the universe used to be very small and very compact, but now it's starting to expand. It's starting to cool down. So what's happening is that, remember I said that in the middle here, huge amounts of dark energy is being poured into the universe. And the strings now are far enough apart that only some of the dark energy is actually turned into dark matter. So there's a couple things. So dark energy is now outweighing visible matter in the universe. And what's happening is that dark matter really isn't affected by radiation, or at least not like visible matter. So at this particular point in time, there are helium atoms and hydrogen atoms basically just floating around. And every time they try to get together, the radiation just blows them apart again. Okay? Now, radiation doesn't affect dark matter. So what happens is that dark matter starts clumping together. Okay, let's say that's dark matter. And they're clumping together this way as well. And this way. And that way. And basically, right around here, where there's kind of like a double whammy, that's where gravity is the strongest. And what happens is that the visible matter gravitates towards that space. And in this age, this is where planets, stars, galaxies start to coalesce. The other thing that's happening is that area of high density of dark matter is attracting areas of low density of dark matter. So what's forming is kind of a web. So you have high density of dark matter, and in here, this is where the visible matter is kind of coalescing, starting to form planets, galaxies, what have you. And here, in the low density areas of dark matter, starts to flow in dark energy. Because it kind of looks like a spider web, what they call it is a dark matter web. So again, in this area, dark matter outnumbered the amount of dark energy. But that is about to change. So the last age is called, or I call it anyway, the age of dark energy. And that happened about when the universe was about 10 billion years old to the present. And as you recall, the universe is expanding. And I'm speculating that in the middle of the universe, huge amounts of dark energy is being poured into the universe. And that is causing the expansion of the universe. And as the universe expands, what happens is that the strings associated with dark energy are now so far apart. And don't forget, the universe is cooling down, so it doesn't have as much activation energy to hold these strings together to form dark matter and visible matter for that matter. We talked about the dark matter web. And what we said was that right around here, where there is a concentration of gravity, that's where the hydrogen atoms kind of gathered. And that's where you kind of formed galaxies and where the visible matter coalesced. And what also happened was with the dark matter, it went from concentrations of low concentration to areas of high concentration. So there was kind of a chasm that was created, and basically the dark energy flowed into those chasms. Also, the thing is that as the energy from the mother universe pours into our universe, what's happening is that the dark energy is increasing in terms of its proportionality to dark matter and visible matter. In fact, if we drew a pie chart, visible matter would only be about 5% of the total energy in the universe. Dark matter would be about 25% of the energy in the universe. And the other 70% of the energy would be made up of dark energy. And as this occurs, because dark matter and visible matter have more gravitational pull and influence than dark energy. So what's happening is that as dark energy comes into our universe, it causes the expansion of the universe, whereas dark matter and visible matter tries to prevent the expansion of the universe by its gravitational pull. So as dark energy becomes more and more prominent, what's happening is that the universe is expanding at a greater rate.